Okay, Alfie. Present. Amirul. Chihab. Angel. Chansa. Chengbunta. I think he is in service, right? Chu Kang. Sorry, Chu Chun Kang. Chia Xiang. Chun Yong. Chun Yong. Chao Kin. Wei Jian. Chua Wei Jian. Ang Sui Liang. Still having lunch because I dismissed late. I believe. Fahima. Wei Jian Chua. Chua Wei Jian is here. Wait, I'm Chifu. Some of them just came. So I just Fahima, Wei Jian marked already. Yang Chifu, Punta Cheng. Punta Cheng. Okay. Wu Yong Chi. Okay, Frenzen. Sorry. Frenzen. Number 9. Okay, marked already. Frenzen. Gabriel. Xin Pro is here. Go Yu Hui. Yu Hui. Tanket Sin Endole. Henry Abigail is always absent. Huang Ningji. Chair. Amirul later, right? Khan Shasta. Lai Su Seng. Imon Laron. Laron. Lim Guang. Lim Jinha. Lim Jiha. Rachel. Rachel Lim. Tai Iman. Mandeep Singh. Thanks, William. Later I'll go back. Wait, let me finish. Muhammad Amiruddin. Around this here. Mandeep Singh is not here yet. Muhammad Amiruddin. Amiruddin is here. Muhammad Sharil. Uh, Ibrahim. None. Nurul. Nurul, are you there? Junha. Oh, Junha. Ong Wei Shu. Elaine. Ong Yan Ling Elaine. Okay. Paul Daniel. Pek Siu Ling. Marcus. Selva Kumaran. Sanish. Sanish, are you here? Lim Siu, sorry, Sim Siu Sien. Tan Chi Hao. Tan Yilin. Darshan. That is here, okay. Tiara. Vanessa. Darren. Tiara. Okay, who's just now? Wei Shuong. Just now someone's name I have not marked. Sui Liang. And Sui Liang, okay. Okay, thanks. Yeah, repeat again. Amirul also just now, right? Amirul also just now I'm answered. Okay. Amirul. Chihao is absent. Okay. Frenson, are you there, Frenson? Huang Ningji, Mandeep Singh, Junhao, or Daniel Morning absent. Okay. All right, let's see. So we're going to learn Boolean algebra. 3 and 4, two different topics. So topic 3, we're going to learn basic logic gates. Topic 4, simplification. Okay, both the topic talk about the same. In this, what we are going to learn in this. Okay, logic circuit diagram. Going to learn here first Boolean algebra. Mainly, we're going to learn about logic gates. Okay, about logic gates here. AND gate, OR gate, NOT gate. So, truth table, Boolean expression. Simplification using Boolean laws or rules. Okay, so these are the four topics we're going to go through for today, both the topics. Take down. Logic gates, only basic gates we're going to learn. AND gate, OR gate, NOT gate, NAND gate. Okay, XOR gate. About 5 gates only we're going to learn. Okay, so first we will learn about the basic gates. Okay, logic gates, then a truth table and expression. Okay, the gates will have many inputs, but maximum we're going to learn 2 and 3 inputs only. Okay, right. Not yet. Not get one input, one output. It looks like this. Okay. Mm, So input, this is the input. When it comes to output, it will be A complement. A complement can represent this way. Invert, it will invert the input. So whatever it goes inside, it will invert the input. So the complement is called like this, or you can represent this or this negation. All these are symbols used for complement. Suppose, for example, I give gates only understand 0 and 1 input. If it is 1 and 0, these two will be sent as the, because they are logic gates. Okay. So 0 and 1 only, it will take it as an input. One, if you send a 0 input, the output will become 1. 0 goes inside the gate, not gate, it will show the result as 1. If you give input as 1, it will change the result as 0. This is called a negate. Now, not gate, invert the input. So complementing, just now we did a 2's complement, right? Invert all the bits. So inverting all the bits, it can, you can use a not gate. Okay. So second gate is AND gate. And works like a multiplication. So AND gate, there are 2 input AND gate available, 3 input, multiple input gate also available. Okay, so for our syllabus, we are using 2 input or 3 input. Okay, so the input is on the left side, output is right side. Okay, so if you give input A, B, 2 different input we are giving, the output would be A dot B. Okay, so we call it as AB. So the symbol is dot. If I give an input A, B, C, any letters, whatever input it gives, it will multiply A dot B dot C and operation. This is the second gate. Okay, third gate. All the gates are inside the study PowerPoint slides there, but they are showing the slides like this one by one, but I'm tabulating all the slides. Where is it? See, all the gates are here. They have given in the topic. Okay, so if you want, you can copy down or you can see also. And not and or gate. So this is the not gate. Okay, and gate. Okay, or gate. Okay, all this. Okay, so I'm simplifying for you. And operation, you can do this way also. And like A and B. And operation. A dot B also can, A and B also can. Okay, some websites they use and is dot, some reference this. Okay, or gate or operation, or is a similar to plus operation, but it is not binary adding, binary addition, it's just plus. Okay, 1 plus 1 is 1 in a Boolean algebra. OR gate, 2 input OR gate is this. It's a similar 2 input, then output, everything is similar, but what is the difference? Difference is this part. AND gate here is a straight line. OR gate here is a curved line. Can you see? Okay. Everything is the same as the AND gate. But how do we differentiate AND gate or gate? AND gate is, it will be straight line. This line is straight, it is AND. Okay. this line is curved, then it is or operation. Understand? Or operation similar to addition. So A or B. It's not A plus B, A or B. Sometimes people say A plus B. Okay, doesn't matter. But it is or. Okay. Either one condition is true. So 3-input OR gate, you get A, B, C, A or B or C, A plus B plus C. Or you can say OR is represented by V. So it's a plus or V. Okay, so this is the symbol for OR operation. These are basic gates, 3 basic gates used in Boolean algebra. Afterwards, combined few gates then form the other types of gates. They combine the gates and form other gates. Those are called derived gates. Derived gates means a combination of 2 gates. Okay, and the basic gates are only these 3 gates: not gate, AND gate, OR gate. Okay, NOR gate, NAND gate. Okay, combination of 2 gates. Number number 4, NAND gate. This is a combination of not plus and NAND. NAND. And gate. How does they combine? Okay. AND gate with the bubble. Okay, so it works as a AND gate, then not. AND plus not is the NAND gate function. Instead of using 2 gates like this, they use 1 gate. But the function is similar to these 2 gates. Okay, NAND and NOT. Okay, so how the input goes here, A and B, like A, B. First is AND operation. So here it will do A dot B, AND. Then this whole thing goes inside the NOT gate. What will happen? The input goes inside, then the whole thing inverted. So how it works? I give 0 and 0. 0 times 0 is 0 here. Understand? A is 0, B is 0. 0 dot 0 is 0. Correct? 0 times 0 is 0. Multiply. Then when the 0 goes inside NOT gate, then it will convert to 1. A dot B is 0. The output is invert of A dot B. So A dot B whole thing inverted is 1. Do you understand? Okay, so that's how the NAND gate works. So here is A dot B. The bubble act as a NOT operation. So when it comes here, A dot B complement. So here you can say A dot B complement. Okay, output, or A and B whole complement, whole thing complement. Okay. NOR gate, same thing, or operation with a complement. Okay. Not plus or, 2 gates combined here. But the symbol NOR Instead of two gates, they use one gate only or with a bubble. This representation is NOR, but it works as a OR gate followed by a NOT gate. Okay, the same concept. A, B goes here. This place, it is A plus B. Then after the bubble, it is A plus B whole complement. Okay. Now here how it works. AB is input. This is OR gate. So here A plus B, the first input plus second input. This whole thing goes inside the NOT gate. Then it will invert A plus B complement. Understand? Right? A plus B complement. So A or B complement. NAND gate. Combination of two gates. Fourth one, NAND. NAND gate. Not an AND combined. Oh, here fourth one. This one is simplification using Boolean laws. Someone's video is on, blocking my screen. Give me a minute. Next, XOR gate. XOR or with the special function XOR gate. I'm going to learn only 6 gates, yeah. XOR gate. Extra curved line here. XOR gate. XOR gate, this is extra. Okay. So A, B, XOR is A, XOR. So the symbol is this. So all the, I put in a 2-page layout. You can view all the 6 gates. So all these are basic gates. It's a single gate, AND gate or NOT gate and OR gate. Or first 3 are basic gate. 4, 5, 6 are combined gate. Combined with the certain gates, then it produces a certain output. So they are called derived gates. Okay, but the symbol is not showing 2 gates. It will be 1 gate, but the operation works as a 2 operation, and not or not. Okay, take down the gates. Then we are going to learn individual gate truth table. Then after that, we will try to find out a truth table for the entire logic circuit diagram. Okay, truth table. 2 input, 3 input gates, we will do the truth table, but for NOT gate is 1 input, 1 output. Other gates all you can have a multiple inputs, one output. Okay. Logic gates are the easiest one. Tiara, very easy. 0 1 0 1. No multiplication, no division. Yeah, 1 0 0 1. That's it. Logic gates. One of the easiest thing. Okay, so if you have done, then we'll carry on the truth table. For each, this topic, one question, it will be there about 20 marks or 15 marks, one full question. You can score very easily this. Okay, right. Because this module, last time about less 2 topics. After that, my doc review, then add extra 2 more topics. Already this module heavy topics, mathematics, lot of things to learn. You have to remember, no choice. And two weekends not enough to do enough practice. Just time is just nice to finish all the chapters only, right? No, we don't have enough time to do extra revision. That's why when I teach itself, I give you exercise. So what you need to do, you practice those exercise again to revise. Okay, right. Math stuff on top of that, so many topics. Okay, so never mind. Okay, let's continue. Truth table. So we're going to learn truth table for each circuit diagram. First gate, not gate. Truth table. Not gate, always one input, one output. So whatever you input, okay, you input A, the output is A complement or this invert A. So how the truth table looks like? Okay, so I'm going to draw the truth table. Truth table is what? Truth table is a table which shows the input and output of the logic circuit, logic gates. Logic gates are input as well as output. What input the gate accept, what would be the output for that particular input. Okay, so this is the truth table. So the the gate has only one input, so which is A. The output is A complement. Okay, X. This is the output. The output is A complement. Okay, so this is the output. This is the input. Okay, so what are the input you can give? If A is 0, you can give 0 as the input, and you can give 1 as the input. There are two types of input only logic gate accept. True or false. 0 means false, 1 means true, right? So the same thing. So if you input 0, the 0 goes inside the gate. When it come out, it will be 1. The value is inverted. Inverted means opposite value will be shown as the output. If you give 1 as the input, the logic gate will change it to 0. The output will be shown as 0. This is the truth table of a NOT gate. Whatever the value it goes inside, it will invert the value. Yes, correct. So that is the truth table of a NOT gate. Okay, AND gate. AND gate 2 input. AND operation is similar to multiplication operation. AND gate. Truth table. AND gate, there are 2 input AND gate and 3 input AND gate. How the truth table looks like, if you happen to see, 2 input, A and B, any letter you can use, A, B, X, Y, Z, anything, okay? So the AND gate will show the result as A dot B. Dot is multiplication. Sometimes they show the symbol A and B. So both means the same thing. They can use any symbol, practice both the symbol. So for an AND gate, the truth table, input A and B, this is the output. A and B are input. Output we call it as X, X, Y, Z, any letter, which is equal to A dot B. Okay, so there are 4 options of input. How do we fill the input so that we don't mix the options or miss the options? There is a way to fill up the input. Okay, so how do I fill up? I tell you the formula is two number of rows in the table is equal to 2 power n. N is the inputs, number of inputs. That is the n. So how many inputs are here? 2 input, A and B. So 2 power 2. N is 2. So it will be 4 rows. The truth table must have 4 rows. 1, 2, 3, 4. You can see. Then how do we fill up each input? First input, which is A. How do we fill? The number of rows you use here, number of rows divide by 2. Why divide by 2? There is only 2 option, true or false or 0 or 1. So always you must divide by 2. Two options only, 0 and 1. So you 4 divided by 2, 2. So the result is 2. So you need to fill up with the 2 zeros, 2 ones, which means A input you must fill up like this. First input, this is A input, filled with the two continuous zeros, two continuous ones. Some reference book, they start with ones followed by zeros. If you are starting with zeros all throughout the table, you must start with 0. Okay. If you're starting with 1 throughout the table, you must start with 1. Okay. So basically, I usually start with the 0. Okay. Two zeros and two ones. Yeah, two zeros and two ones. That's how you must fill up. So second input. After that, second input. How do we fill? Okay. So you take this value, you use here 2 divided by 2. Always divide by 2, I said 1. So which means 1 0 1 1. So which means here you fill up 0 1. 0 1. Like this you must fill up. This one you no need to show how to fill up this part. This part no need to show in the exam. This is for your knowledge, because in the reference books or internet, they will not explain this portion, which I seldom people explain. Okay, but this is the right method of filling up the truth table, but you can't find it very easily in any reference guide. Okay, this is the way of filling up the truth table. Okay, so once the once the input is filled up, sorry, this mistake. Thanks for highlighting. Was someone highlighted, and is this symbol. Thanks. Thanks, Yuling. Correct. And is right, this symbol. If I put this means or. V is or. Inverted V only and. Thank you, thank you. Just now I made a mistake here. Okay. I've corrected. Okay, so once the table is filled, then we can able to do the output. So what happens? This combination we're going to test. Okay, when A is 0, B is 0. What will happen? The AND gate does the multiplication. 0 times 0, the output is also 0. Okay, it will show the result as 0. Okay, you no need to write in the on the here, but first gate I just write and explain. Okay, next combination 0 1. What will happen? A is 0, B is 1. So 0 dot 1. So the answer is 0. Anything multiplied with 0, it will be 0. So the AND gate also show the output as a 0. Next combination 1 0. A is 1, B is a 0. A is 1, B is 0. So 1 dot 0. Also 1 multiplied with the 0 is 0. So this also 0. The output would be 0. Now next combination 1 and 1. A is 1, B is also 1. 1 times 1 is equal to 1, right? So here is 1. So this gate respond when all the inputs are 1. Any one of the input is 0, the output would be 0. Understand? Okay. So this is the two input AND gate. So the same truth table will do for a three input. Again, three input AND gate. A, B, C, A dot B dot C. Okay, three input AND gate. So how many rows for this truth table? Number of rows is equal to 2 power 3 because 3 input. So 2 power 3 is 8 rows. This table is supposed to have 8 rows. A, B, C. This is the input. A, B, C. Output is A dot B dot C. Okay. How many rows it's supposed to have? 8 rows. 2, 4, 6, 8. 8 rows. Okay, this truth table is supposed to have 8 rows. Okay, so how do I fill up this? Okay, first input A. So we take this here, divide by 2, 4. That means 4 zeros, 4 ones. Okay, 1, 2, 3, 4. 4 continuous zeros, 4 continuous ones. Okay, second input B. How do I fill up? I use this here. 4 divided by 2, 2. So 2 zeros, 2 ones. So how do you fill up? 2 zeros, 2 ones. Again 2 zeros, 2 ones. Understand? Third input C. We have to use this. 2 divided by 2, which is equal to 1, 1 0, 1 1. So here 0 1. Again 0 1, 0 1, 0 1. Like this you must fill up. Okay, again this is not required. This portion is not required, but just for a knowledge I'm showing. Okay, so the input and output only you had to show. So what would be the output for this gate? Okay, so output would be all 0. 0 times 0 times 0 is 0. 0 times 0 multiplied with anything is 0. Again 0 multiplied with anything 0. 0 multiplied with anything is 0. 1 times 0 is also 0. 1 times 0 is 0. Again multiply with the 0 is 0. Only when all the inputs are 1, the output is 1. Understand? So this is the 3 input AND gate truth table. You must just know how to fill up 3 input, 4 zeros, 4 ones, 2 zeros, 2 1, 1 0 1 1. 2 input means same thing, 2 0 2 1, 1 0 1 1. Okay, this is the first one.
Sorry, ma'am. Can I ask? So the question in the exam will probably be given
No,
like,
I haven't come to question.
oh,
Question
so
later. This is just learning first. No question is asking for only one gate. We will be doing logic gate diagram. This is the one, logic circuit diagram. So logic circuit diagram will have multiple gates combined.
so
When you
will we be
combine
tested
multiple
to write
gates,
the
then
truth
you have
table?
to draw a truth table for the entire circuit diagram. In order to learn, write the entire circuit diagram truth table, you need to know individual truth table. Then only you will combine with the other gate, the final truth table you will come out. Understand? So we are learning individual gates truth table. Then we will learn a lot of entire circuit diagram truth table. Okay? Is that okay?
Yeah.
Okay. Why always divide by 2? Because we have two options only, 0 and 1. Gates only accept two inputs, 0 or 1. That's why always divide by 2. Iman, okay? So we divide by 2 here. Okay. Okay, have you taken this 2 input and 3 input? Okay, the rest of the gate, I'm going to just show the gate and truth table. I will not explain how to fill up the rows, column, inputs. They will not ask you how to fill up, but this is the right way to fill up. If you don't follow this, you will miss out certain combination, and you will repeat certain combination. Okay, what I mean is the combinations means this part, this combination. Sometimes you repeat the same combination again, or you will miss out certain combinations. Okay, so to avoid that only, this is the method they follow to fill up the truth table. Okay, some gates will have 5 input also. Then 5 input, very difficult to fill 5 zeros and 4 zeros, 1, and then the combination is tough. So this is the format of filling. Done already. 3 input and gate taken. Okay. Now we're going to do OR gate truth table. Individual truth table you must know how to do. Then only final the exam question will combine the gates and then ask you to draw the truth table. It would be easy. Okay. Right. Okay. Now moving on to, I just started the topic. Okay. The final question is, exam question is not individual gate. It's combined gate. But individual gate you do not know, then combined gate you can't do. Okay. So I'm teaching the basic parts in the topic. After learn the basic parts, then it comes to exam questions. Okay. So now OR gate truth table. Two input OR gate and 3 input. OR gate is a curved like this. A, B, or output X is going to be A or B. Okay, that is equal to A or B. R is like V, and is inverted. So the truth table, again, 2 input, 4 rows. A, B, output is A or B. Okay, so 4 rows. Filling 2 zeros, 2 ones, 1 0 1 0 1. Okay, or is like a plus operation. So suppose we are going to use the first combination. A is 0, B is 0. 0 plus 0 is 0. So the output would be 0. Both 0 input, the output is 0. Okay. So now second combination, 0 and 1. A is 0, B is 1. So 0 plus 1 is 1, or behaves like a addition, but it is not exact addition or combination, this or that. Either one condition is true, the gate works fine. It will it will be true. Okay, so A is 0, B is 1, 0 plus 1 is 1. Okay, next combination, 1 plus 0. A is 1, B is 0. 1 plus 0 is 1. Again, the output is 1. Okay. Now, 1 plus 1. Both the input 1 and 1. 1 plus 1 also, the output is 1. Because logic gate is not binary addition. 1 plus 1 is 2, right? But logic gate either 0 or 1. Understand? So even one of the input is 1, it will show 1. So which means as long as this gate, when it works, as long as any one input is 1, the output is 1. It works fine. No matter the other input 1 or 0. Okay? Understand? Any one is input is 1, it will work as a 1. The output is 1. So in Boolean algebra, not binary, we call it as addition, but in a Boolean algebra, 1 plus 0 is 1. 1 plus 1 also 1. Okay, so the two types of input only we are going to give for logic gates. In Boolean algebra, 1 plus anything, 1 plus anything is 1. The anything can be two types of input. What are the two types of input? The anything can be either 0 or 1. 1 plus 1 also 1. 1 plus 0 also 1. Understand? The anything can be two option only, 0 or 1. 1 plus 0 also 1. 1 plus 1 also 1 in a Boolean algebra. Understand, class? So don't confuse with the binary addition. Okay, right. Next, three input. Same thing, only table changes. So here three input means the table must have 8 rows. B, C. A plus B plus C, or okay. Okay. So again, filling up 4 zeros, 4 ones, 2 0, 2 1, 1 0, 1 0 1 0 1 0 1. So once you fill up all 0, input is all zeros, the output is 0. Okay, so 0 plus 0 plus 0 is 0. All right, it works like an addition, I told you. So the output is 0. Any one input is 1, the output will be 1. So 1 plus 0 is 1. 1 plus 0 is 1. 1 plus 0 is 1. 1 plus 1 also 1. So as long as the input is 1, you can output, the output is 1. Understand? So, OR gate is done. NAND gate. Third gate, truth table of NAND gate. Okay. NAND gate also 2 input or 3 input. 2 input NAND gate. So NAND gate is a combination of NOT and, but NAND gate does the AND operation first, followed by the NOT operation. I'll just draw for you to your own understanding. Means the same, both means the same. We will call this AND gate, NOT gate, but this is the NAND gate. This is the AND NOT, AND plus NOT gate. This is called a NAND. One gate only, NAND operation. Okay. So the bubble does the AND operation. Okay. So here A, B, here A dot B, and does the AND operation. After it comes, then it will be complement. First multiplication after the complement. Understand? A, B, I multiply. This is the output. Multiply and complement. Okay, so these two are input. This is the output. Okay, so what will happen? Fill up the values. 2 zeros, 2 ones, 0, 1, 0, 1. Okay, so when I send this is AB, AB, this is AND gate, here will be A dot B, then it goes A dot B goes inside, it will be A dot B whole complement. Understand? So now how this gate works, NAND gate. When I give 0 and 0, I'm giving A is 0, B is 0. This will be 0 times 0 is 0 output. Then when it goes to NOT gate, it will become 1. Do you understand? Same operation here. 0 and 0. Here, this part AND operation, A dot B. So it will be 0. A and B goes inside and it will be multiplying 0 times 0, 0. Then the 0 goes inside the bubble. Bubble act as a this one act as a NOT gate. NOT gate. So if the 0 goes inside the bubble, it when comes out, it will become 1. Understand? It will invert and come. Okay. So NAND gate multiply and invert. Is that clear? So I'm going to write the answer here. First, this column I'm going to fill up. 0 times 0 is 0. 0 dot 1 is also 0. 1 dot 0 is also 0. 1 dot 1 is 1. That is the AND gate. Then once it multiply, it invert. The entire column, it will invert. So if it is 0 here, this will become 1. This is 0, it will become 1. This is 0, it will become 1. This is 1, it will change to 0. Understand? multiply and then invert. Okay, so I'll invert. 0 will become 1, 1, 1, 0. Truth table now. Truth table and get multiply. After multiply, the same thing goes inside this not gate. What will happen? This is multiplication, correct? This is AND gate. AND gate does the multiplication. Multiplication result is 0 times 0, 0. 0 goes inside here, it becomes 1. So I'm showing here the 0 and 0, it multiplies to be 1. 1, and then when it comes out, it becomes, sorry, multiplies, it becomes 0. When it comes out, it becomes 1. Understand? Not gate inverts the value. After not gate doesn't invert. You see here, 0 goes inside, then this is AND operation. Here will be 0. 0 is this portion. So the bubble will invert the 0 into 1. This 0 will become 1 after the bubble. Understand? All right. So it multiply and invert. That's what I mean to say. NAND gate will multiply the input. After that, the result will be inverted. Understand? That is the NAND operation. Okay. So it multiplies A dot. Here will be A dot B. When it comes out, this will be A dot B invert. The line is called invert. Invert or complement or negate. Yes. Complement means the value will be reversed. Okay, so let's do again for 3 input. And 1, 2, 3, 3 input, then bubble. So you have A, B, C. The output is A dot B dot C and complement. Okay. So now 3 input means you need 8 rows. A, B, C, A, B. I will put extra one column. Extra one column, I multiply first, then invert it. A, B, C. This is A dot B dot C. Here will be A dot B dot C complement. Okay. So let's fill up the columns. 4 zeros, 4 ones. Listen carefully. Those who don't understand. 2 zeros, 2 ones. 0 1, 0 1, 0 1, 0 1. Okay. So let's take this combination. So what will happen? The input is A is 0, B is 0, C is 0. So it multiplies. This gate multiplies. A dot B dot C. 0 dot 0 dot 0 is 0 here. It multiplies. Then it inverts. It becomes 1. Understand? So the result here is 0. Multiply, it's 0. Invert, it will become 1. The result inverted. So this multiplied result get inverted. This is the output. Actual output is this. These are input. So it multiplies and invert. So the multiplication you will not see. But we want to show in the truth table, you can show the multiplication result. After that, the result get inverted. Understand? It multiplies first and then invert. Is that clear, class? Okay, right. Second combination, we straight away go to the table and write. Okay, 0 times 1 is answer is 0. Multiply, invert is 1. Understand? 0 times 1 times 0 is the multiplication is 0. Then invert, it becomes 1. The NAND gate multiply, then invert. Okay, multiply first, then invert. It multiplies the input and invert the result. So multiplies the inputs, it's 0, invert will become 1. Again, 0, invert 1. This is also 0, it will invert 1. It will be 1, then it will invert to 0. Understand? Because it does AND operation, after that not operation. That's why it's called NAND. AND plus not. Multiply, invert operation. Understand? Okay. Same way it goes to OR gate. OR gate is the, now instead of multiplication, you can do addition. So the input, the truth table, it's there in the slides. Let me share. Truth table, huh? Okay, so OR gate truth table is this. Okay, the input is A and B. A and B. So it can be any letter, uppercase, lowercase, doesn't matter. So this slide, they started with ones. Okay, you can start with zeros. I will show you with the zeros here. A, B, A or B. 4 rows. 1, 2, 3. Okay. 0, 0, 1, 1, 0, 1, 0, 1. Okay. So A is 0, B is 0, answer is 0. A is 0, B is 1, answer is 1. 1 plus anything is 1. 1, 1. This is the OR gate truth table. 2 input OR gate. Let's say we want to do 3 input truth table. 3 input is not shown in the slide, but I will do for you here. 3 input truth table. Okay, so let me erase. I draw here itself 3 input truth table. A, B, C. Here would be A plus B plus C. The truth table I'm drawing here. A, B, C. This is A plus B plus C. This is the output. Okay. So I'm going to fill up 4 zeros. Can see clearly? 4 zeros, 4 ones. 2 zeros, 2 ones. 1 0 1 0 1 0 1 0 1. Okay. So the same thing. Zero plus zero plus zero is zero. 0 plus 0 plus 1 is 1. 1 plus anything is 1. As long as there is 1 here, it will become 1. As long as 1 in the input, the answer is 1. 1, 1, 1, 1, 1. So this is the 3 input OR gate. Correct? So the NOR gate, how does it works? Okay, NOR gate is the same thing. Where is the NOR gate? Let me go up. NOR gate. NOR gate is, you can see here, NOR gate similar to OR gate. Just now I went through, right? So the OR gate plus NOT. NOR is a OR plus NOT combination. It does the OR operation. After that, it will invert. Okay. OR plus NOT. Okay. First, it will do the OR operation. After, it will invert. So the 2 input OR gate A, B, A plus B. Then here A plus B invert. After plus, it will invert. Okay. So now you can see this. 2 zeros, 2 ones, 1 0, 1 0 1. Okay. So AB goes here 0 0. Here it will be 0 plus gate. This is the OR gate. This is the NOT gate. So first OR gate will give you answer 0 plus 0 is 0. Understand? A plus B is 0. 0. 0 plus 0 is 0. Then the 0 invert will become 1. This one come out, it will become 1. Understand? 0 plus 1 is 1. Then it will invert to become 0. 1 plus 0 addition is 1. Invert will be 0. Addition is 1. Invert will be 0. Understand? NOR gate. 2 input. 3 input also same. 3 input. I'm finding a space. I erase and draw for you. 3 input. NOR gate. Or with a bubble. As I mentioned, A, B, C, here A plus B plus C whole complement. Okay, so NOR is the combination of OR operation plus NOT operation. So which one first? OR operation first. After that only invert, complement. Okay. A, B, C, A plus B plus C, then complement. A, B, C, A plus B plus C, A plus B plus C whole complement, the line here. Output is this. Okay. So fill up value, 4 zeros, 4 ones, 2 0, 2 1, 2 0, 2 1, 0 1, 0 1, 0 1, 0 1. Okay. Now what it's going to do, take this combination, 0 plus 0 plus 0 is 0, and this is OR. Afterward, it will invert. 0 will become 1. This will be 1, then invert will be 0. 1, invert is 0, 1, invert is 0. 1 plus anything is 1, right? 1, 0. 1 will become 0. Add is 1, invert is 0. This is the NOR gate truth table. Okay. Next, XOR gate. Okay, XOR gate is this XOR gate truth table. XOR gate truth table, how it works is, if the two inputs are same, 0 0, the output would be 0. Two inputs same two inputs, the output will be 0. A is 0, B is 0, the output will be 0. A is 1, B is 1, the output will be 0. Both the inputs same, the output will be 0. When this gate will work, one input, both the input different, then only it will be 1. Or A is 0, B is 1, then it will be 1. Understand? So, two inputs different, then the output will be 1. If the two inputs also same, 1 and 1, it's 0. 0 and 0, also it will be 0. Okay, that is XOR gate. Okay, 3 input, bit tricky. I'm going to draw for you. 3 input XOR gate. What is the input? A, B, C. A XOR B XOR C. Okay. This XOR operation looks like we did in what is that called? Cumulative sum in MATLAB, something like that. A, B, C, A XOR B XOR C. Okay. Four zeros for ones, 2 0 to 1, 0 1 0 1 0 1 0 1. Okay, as I told, XOR gate, all the inputs same, output is 0, correct? So in this case, 3 inputs also same, 3 inputs also same, the output would be, by right, it's supposed to be 0, right? By it is not. Okay, so you cannot that way. That is only 2 inputs. Now coming to here, we have to do as a cumulative sum. First, we need to add these 2 columns, these 2 XOR operation. So what is the result of this XOR operation? Okay, so I need to erase. A XOR B, here A XOR B XOR C. Okay, now we are going to deal with these 2 only. We are going to deal with these 2 XOR operation. Now you see 2 inputs same, 2 inputs same, 2 inputs same, 2 inputs same, then the output is, what is that? 0, 0, 0 and 0. Understand? Yes, sir? No, class. Are you there? Okay. Right. The 2 inputs different. The 2 inputs different. What would be the result? The answer is 1, 1, 1, 1, 1. Correct? Very good. Okay, now done. Now what we have to do? A XOR B is done. Now this result have to, this part is done. Now this result, the result have to add with C. Now we are going to do with these 2. A XOR B XOR C. Adding this result with the C, correct? XOR operation. Okay, understand? These 2 we are going to combine. XOR A XOR with the C. Okay, now we look at this. Now we highlight, let me erase this. Sorry, give me a minute. Now I highlight which two are same. Two inputs same, two inputs same, two inputs same. What would be the result? 0, right? Input same means the output is 0. So here the output is 0, 0, 0, 0. The remaining, the input is different, right? So this one, two input different, two input different, two input different, two input different. So what would be the answer? Answer would be 1, 1, 1, 1. Understand, class? This is how you must work. Cumulative. Add 2, then the result add with the third item. First you add 2 inputs, the result add with the third input. Okay. It's not A, B, Tiara, it is A XOR B. A XOR B means the XOR operation. What it says is XOR operation, the two inputs. If you give A is 0, B is 0, the output would be 0. Two inputs also same, the output would be 0. If A is 0, A is 0, B is also 0, the output would be 0. Okay. If A is 1, B is 1. Also 0, the output. Because A or B same value, the output is 0. If you have A and B different value, then the output will become 1 in XOR operation. A is 1, B is 0. Different value, right? The output will be 1. If A is 0, B is 1. Different value, the output will be 0. Okay? All right. So we have learned all the gates, individual gates truth table for a 2 input as well as 3 input. Okay, now we're going to combine the gates and see how to draw the truth table for the combined gate. Okay, all individual gate. Logic circuit diagram is combination of logic circuit diagram is a combination of logic gates. Okay, when you combine logic gates, then you can create a CPU, you can create a register, multiplexer, amplifiers, all comes with a combination of logic gates. Okay. So this is the logic circuit diagram. So here we combine two gates. Okay, first gate is OR gate, second gate is AND gate. So this is called logic circuit diagram. What would be the output of this gate? Or AND. Okay, what would be the output of this gate? Okay, let's say the input is A, B. Okay, so we will come out with the output of this, the entire circuit diagram. How do we get the output of entire circuit diagram? We do one by one. First gate output, then the second gate output, the final output. First gate, the first gate is OR gate. Input is A and B. The output would be A or B, A plus B. Correct or no? For this gate, this is the output. This output is coming here and joining the second gate. Then one more input is coming. So for second gate, this is the first input, this is the second input, correct? So AND operation, how do we write? The first input is A or B. This is the first input dot second input C. This is the output expression. So We write here the output for this gate. The output for this gate is, let's say, x equals a plus b dot c. This is called a final expression. So this expression is called a Boolean expression. When you write the final result, right, in terms of A, B, C, then it is called Boolean expression. Okay. So if you happen to see my notes, the topic exam questions are in this topic, exam questions will be tested on these 4 items. One is truth table, second one is Boolean expression, third one is logic circuit diagram, fourth one is simplification. What is Boolean expression? Number 2. Number 2 is nothing but writing this final output expression for the logic circuit diagram. Then it is called a Boolean expression. Okay. What is logic circuit diagram? Number 3. Logic circuit diagram. The logic circuit diagram is nothing but a diagram with the many gates combined. It's called a logic circuit diagram. Okay, what is truth table? Truth table is showing the input output of the gates. One gate or multiple gates, whatever, how many gates they are there, we have to draw the truth tables to show all the outputs of the gates. That is the truth table. Okay, 3 components. Okay, let's try here. How do I draw the truth table for this diagram? Okay, truth table for this diagram. How do I draw? Let me draw the diagram first, then come out with the truth table. So they say A, B, C. What is the X? So we already say first gate is this OR gate. So A plus B is the output. This A plus B is coming here. From here it's coming here. This C is going to the second gate, AND gate. So AND gate is first input dot second input. So the X is equal to A plus B is coming dot C. You can put the bracket. Bracket is better to show the first input dot second input. In mathematics, having brackets will be safe. Having additional brackets will be very safe. Okay, without brackets. You use with the bracket, it's easier. So this is the Boolean expression for the circuit diagram. The X is the expression and a Boolean expression. Now truth table. How do I draw truth table? Truth table must show how many gates, that many gates output has to show in the truth table, input and output. So in order to draw the truth table, how many letters are there? How many letters are there? 3 letters, A, B, C. The inputs are 3 inputs, A, B, C. Sometimes the same input repeated again. B is used again and again. C is used again and again. That doesn't matter. In the total circuit, how many letters are there? 3 letters means 3 inputs. Understand? So in this case, this circuit diagram, 3 letters are there, 3 inputs, A, B, C. Okay, so 3 input means 8 rows. A, B, C. A, B, C, 4 zeros, 4 ones. 8 rows means always 4041. 2021 10101. You have to fill up the first all the inputs. Now you need to fill up one by one gate. This output. Okay, first gate, the output. Okay, first gate output. This output. So now we're going to show the output of A plus B. Okay, so in order to have A plus B, you have to take this A column, B column. Okay, so 0 plus 0 is 0. 0. 0 plus 1, 1. 1. 1 plus 0, 1. 1 plus 0, 1. 1 plus. So you are done this part. Okay, first gate output is done. So now move on to next gate output. You have to show this gate output. This gate output. This gate output is you're going to use this column. You're going to use a C. These two. You combine and show the X. The X is equal to A plus B column multiply with the C column. Correct? Yes or no? You multiply these two columns and show the result. 0 times 0 is 0. 1 times 0 is 0. Okay, 0 times 1, 0. 1 times 1, 1. This is 0, 1, 0, 1. That's all. Earlier, someone asked me, unmuted the mic and asked me, right? The exam question is going to be like this. Yes, the question is not going to ask you individual gate truth table. They will ask you the a truth table of the entire logic circuit diagram. So in the circuit diagram, two gates are there. You need to show the result of entire gate, two gates output. So first gate output is this gate output is this gate output is this. Okay, all the gates output have to be shown. So we have to do one by one, gate by gate. That's why I taught you individual gate truth table, how we have to create. So once you know individual truth table, how to create, you can create the combined logic gates truth table. Is that okay? Understand, class? Okay, let's try to see is there any other exercise. So Boolean expression I explained. This is called Boolean expression. Yeah, the output, final output of the entire logic circuit diagram shown in terms of letters. That is Boolean expression. So what will happen when I put a NOT gate here? Whatever we give here, this is the input going here. So what would be the output? The entire thing is inverted. A or B and C whole complement. Invert. Correct? Follow the order. Vaishu. You must follow the order of the gate. Okay? Follow the order of the gate. I will show you the. You see here? First gate, then the order of the second gate. You have to keep adding. First gate, second gate, third gate. Why this is third gate? You must have 2 and 3, then only you can do the fourth. Without 3, fourth cannot. Understand? I will show you some gate then. So first gate, second gate, third gate. This is fourth gate. Okay. Suppose this is coming and joining here. Then what is the order? What would be the order, class? 1, 2, 3 is okay. Now for this, then this is fine. This is the final. Understand? Why? Because 5 cannot do without 4. So you must follow the order. Huh? So these are examples. So I'm going to give you some example to try. Truth table and Boolean expression. Shall we have a break now? Afterwards, we will do the exercise. One, two, this is 3. Okay. In this case, what is the order after 3? Can you tell me? Which would be 4? Number A or B? Which will be 4, class? This will be 4. This will be 5. This will be 6. Okay. Understand? That's how it goes. Goes in the order. Okay. So later we will do the exercise on that. We will have a break. 15 minutes break. I need a break for my voice. Okay, after break I will continue. Okay. Class, are you able to see? Okay, so this is the exercise for us to try. Okay, for this diagram, the question would be like this. Okay, in exam paper. Down. Take down the diagram. I'll write the question. I'll just copy this. Take down this two image. We will Okay, I'll stop sharing. Two questions to practice. Okay, so this type of question you can expect in the exam. Okay. Okay, take down these two questions. So come out with the Boolean expression and a truth table. Okay, first one I will show you. Okay, so first one, this is AND gate dot OR gate not gate. Okay, so first gate is this. So first gate output would be A dot B. X is A dot B. Okay, this is the second gate. From where the input is coming, you can see here from B it is coming. So here input is B. So Y is equal to B complement. Correct? Then the third gate. Third gate output is this X and Y. So X value is A dot B plus, or is a plus, right? Plus B complement. This is the answer. Expression, Boolean expression is Q is equal to A dot B plus B complement. You must write it. Answer for number one. Okay, number two. Truth table. Truth table is how many inputs they are using? Class, tell me how many inputs they are using in the first diagram. Two inputs. So you must have two inputs only, two letters only, A, B only. You don't talk about Q. The Q is just the output. Inputs. How many inputs are there? A and B only. Correct? Two inputs. So we need to draw a circuit diagram, truth table for two inputs. So I'm going to have a truth table. Okay, so truth table here. Okay, so this is I'm going to write here. Okay, so this is A, B. 0 0 1 1 0 1 0 1. Correct? Okay. So these are the two input. So now the first gate, this gate output I'm going to do, number one gate output. So what is number one gate output? A dot B. So you need to combine these two columns. 0 times 0 is 0, 0, 0, 1. Okay, we have done this. Then the second gate output, we've done this, we are doing this. Second gate output is B complement. B complement. B complement means what I have to do, take the B column, invert it. This column, you invert here. Okay, so what will happen? 0 will become 1, 1 will become 0, 0 will become 1, 1 will become 0. Correct? So far, okay? Understand, class? Okay, we are done this portion. Now we're going to do the last portion. Last part is this part. Third gate. Third gate output is this. So what is that? Q equals A dot B plus B complement. Okay, where is A dot B? A dot B is here. Okay, this part. Where is B complement? B complement is here. Okay, this. We are going to combine these two. So we're going to combine these two columns. So when you combine these two columns, what would be the output? Plus, right? 0 plus 1 is 1. 0 plus 0 is 0. 0 plus 1 is 1. 1 plus 0 is 1. So this is the truth table. Okay. Do in the order of how you have solved your logic gates. Understand? Go in the order. First one, second one, third one. Dot plus. Or if you are using this symbol and this symbol also can. So this will be shown as Q is equal to A and B plus B complement. All right. So like this question would be expected in the exam. Okay. Try. So try to do this next question. So first one is A input with a NOT gate, A complement. Second one is A is coming to here or gate B. So the output is A or B. Okay. Third one is the A or B is going here A complement. So A complement dot A plus B. Correct? So fourth gate, these two are going. Okay. So Z equals the whole thing is first input, then second input. So you can have more than one bracket you want to show. Okay. Z equals not enough space. I'm writing here. A complement dot A plus B. This is the first portion for fourth gate. Or this is the first input followed by second input plus A plus B. This is the final expression, Boolean expression. So number one, Z equals A complement dot A plus B plus A plus B. This is the Boolean expression. Now truth table, you must do one by one, each gate. But how many inputs again class here? How many inputs they use? 2 inputs only. 3 inputs means you must put the truth table 8 rows. Understand? So this is the table. A complement A plus B. A dot A plus B. Yeah, so the truth table A and B. 0 0 1 1 0 1 0 1. Okay. Then first number one is the A complement. First gate output is A complement. So I'm going to show A complement. So the answer is you take the A column, invert here. Okay. So A complement. So what it was going to show is A is 0. Here it will become 1, 1, 0, 0. Opposite of A, right? So A column, you just invert. Take the A column and change the values, A complement. Okay, number 2. Number 2 is this. Now we're going to do AB, A plus B. So we need to take A and B, combine. Okay, 0 0 0 1 1 0 1 1. So I'm going to write the answer 0 plus 0 0 0 plus 1 1 1 plus 0, 1. 1 plus 1 is 1. Okay. So you do step by step, easy for you. Huh? Okay, done. Then next, third gate output is this. Third gate output is A complement dot A plus B. The expression only looks very big, but in a truth table, very simple. You're going to do one column or two columns only. A complement is this column. A plus B is this column. We are going to do these two columns, multiplication. Correct? A complement with A plus B. So take the A complement column, multiply with A plus B. So is 0, 1 time 1 is 1, 0, 0. Simple, right? The expression looks big, but actual table is 0 or 1. You will be combining two columns at the most. Okay. Now, fourth fourth gate. First output is this portion. This portion is here. Second output is this portion. This is here. These two columns we're going to add. This is first part, this is second part. We're going to add. Okay, add these two. So Z equals A complement dot A plus B plus A plus B. So these two column only. So now here 0 plus 0 is 0. 1 plus 1 is 1. 1 plus 0 is 1. 1. This is the answer. So instead of 4 rows, 8 rows also same. Amita? Sorry, yeah. Yes, your Boolean expression is wrong means the whole question will be wrong. So you must be careful. Huh? First part you make it wrong, then the entire second part portion also will become wrong. You must be careful. Huh? Okay, next question would be, they give a expression, they ask you to draw circuit diagram and truth table. Copy down first. I'll try to give you question. Sorry, I want to share this document with you. Okay, let me. Expression. I'm trying to find the expression for you. Don't have. Okay, maybe. Okay, so I will give you the expression now. To draw the circuit diagram. Okay. Okay, take down this question. We're going to draw the circuit diagram using this expression. Okay, so I'll give you easy way to draw the circuit. Total, how many inputs are there, class? 3 inputs. Actually, you can draw like this individual input like this, like individual input like this. Usually, um, I usually do is I'll create a 3 input as a three straight line like this. Then I draw the circuit diagram. Usually, I'll create 3 lines. 3 lines is like 3 wires. Yeah, A, B, C, 3 inputs, correct? So I will try to do first left to right this part. Okay, right. So you want to take in this portion, you need two inputs. So I will put dot here, then I draw like this. So it's what is the representation? The input is coming from A. Okay, so this is A, then I'm taking B, then what is this operation? Operation is plus, so I need a OR gate. OR gate. Okay, so what will happen? This is A, this is B, OR gate will give me A plus B. But I need a line here, complement. When do I get a complement? Okay, this is A plus B. When I have a bubble will change the A plus B to complement. Do you understand? Do you understand? Okay, so the complement A plus B. Okay, so A plus B plus the bubble. Bubble will convert the A plus B into complement. So this part is done. So second portion. This is the first portion. Okay, now second portion. I will draw again. So second part, I need a B complement. So I'll take B. From B, I will take, I need a B complement. So I take B input. I put a NOT gate here. NOT gate. So individual input complement, you have to put a NOT gate. So the B is here. B input is going in. Once it goes inside the NOT gate, it will become B complement. Yes. Then you need a C. So from here, you draw thing here. This is your C. What they ask you to do, plus. So again, this is a OR operation, OR gate. So this will give you B complement plus C. So this is one input, this is another input. Now we need to combine these two. Correct? So combining, so the lines too far away, very difficult to draw this gate. So one of the line you bring closer like this, closer like this. Now again, the symbol here is a plus. So OR gate, then this would be your X. What is the X? X is equal to A plus B whole complement plus B complement plus C. Yeah. Easy to draw the circuit, logic circuit. Again, you must do in order. Yeah. Selva Kumaran, your question about this, okay. See, A, B, or gate, so this is A, B. Here, if I draw A plus B, right? If I put an OR gate, the bubble here, it will take complement. Is this equal to, Selvakumaran's question, is this equal to, if I write like this, is this same? This is A, here A complement, B, B complement. Can I use this? So what would be the answer here? A complement plus B complement. So is A plus B whole complement equal to A complement plus B complement? Is this same? Actually, it is not same. The whole thing means this whole thing is not equal to individual complement. It's wrong. Okay, so this is different, this is different. If they are equal, the truth table will be equal. So let's draw the truth table for this. First diagram, truth table. A, B, A plus B whole complement. AB is 0, 0, 1, 1, 0, 1, 0, 1. Okay. A plus B is 0. This is A plus B. This is A plus B whole complement. A plus B is 0. Complement is 1. A plus B is 1. Complement is 0. A plus B is 1. Complement is 0. 1 complement is 0. This is the first truth table. The second diagram, truth table. I want to compare the truth table. So first I draw the truth table here. Second diagram, truth table is this. A, B. Okay. 0, 0, 1, 1, 0, 1, 0. So now A complement we want and B complement we want. A complement would be A column inverted. Correct. So A column inverted, 0 will become 1, 1, 0, 0. B complement would be B column inverted. So take the B column, invert it, B complement. Okay. So that would be 1, 0, 1, 0. Now what it is showing, you are adding A complement, B complement. A complement plus B complement. You are adding these two. Okay. Right. So 1 plus 1 is 1, 1, 1, 0. Now you look at the both the two table. Are they same? Is the output same? Not same. Huh? So the two circuit is not same. Understand? This is a NAND gate. Sorry, this is a NOR gate. This is a NOR gate or with the complement. This is a OR gate. NOR and OR is not same. Understand? So don't ever think A plus B, the whole complement is equal to A complement plus B complement. Is instead of writing this, can I write this? No, they are not same. Okay. Later we will know the things in the Boolean rules. Understand? Okay. So good question, Salva Kumaran. Don't. So this expression we want to draw truth table. Truth table. We want to draw 8 rows, right? How many inputs for this table? This okay, already New Waynon has given the truth table. Okay, so maybe never mind. I'll just do 8 rows because 3 inputs, so 8 rows. Mm, Okay, so now 3 input. So we're going to do one by one. Suppose the expression also same way. We're going to do the first gate. First of all, we need to have a ABC. One more. So first ABC input. ABC. Okay. ABC. So first let's fill up 4 zeros, 4 ones, 2 0, 2 1. 0 1, 0 1, 0 1, 0 1. Next, this gate. This is the first gate. This is the first gate. So first gate, I need AB first. So what I'll do is I take these two column, then I write A plus B. A plus B is 0, 0, 1, 1, 1, 1, 1, 1. A plus B. Now I will do the complement. Next, I'll do this line, complement. So complement is take this column inverted. Okay, so A plus B complement. A column invert it. A plus B column invert it. So when you invert, the 0 will become 1, this 0 will become 1, all the ones will become 0. Okay, so the first uh, first part of the expression done. Okay, so this whole thing is done. Next, I need this. Okay, so now I will write a B complement. B complement, I take the B column, invert it. So B column 0, 0 will become 1, 1. 1, 1 will become 0, 0. Again 1, 1, 0, 0. B column, B complement. Next, I am going to do this B complement connect with the C. So it means this connect with the C. These two columns you combine. Okay, B complement plus C. Okay, 1, so what is the C plus B complement? 1, 1, 0, 1, 1, 1, 0, 1, 0, 1, sorry, 1, 1, 0. This is 1. This is also 1. This is also 1, 0, 1. Okay, correct. Okay, verify again if you have doubt. Now this part. This part is simple. So you have a AB whole complement. AB whole complement is this column. B complement C plus this column. These two columns we are going to combine. Okay. It's a plus. So 1 plus anything is 1. That's all. You wait. No, no, your answer, my answer is slightly different. Where is the, it's slightly different, where did I go wrong or your side? Actually, where's the difference? A plus B is there. Why never make the complement? A plus B whole complement. New way, none. So you forgot to do this part. Are you there? Yeah, this part is you missing. What I'm highlighting. This whole column is missing. Other part is correct. This part is right. This is correct. This is correct. These two is correct. This portion also correct. Only you miss this, then this is going to wrong. Oh, but this portion where you went wrong, B complement plus C. 0 and 0 is 0 what? 4 input means 16 rows, but the exam they will not ask you 4 inputs. They will ask you only 2 inputs and 3 inputs only. Okay, there is no 4 inputs for the exam. Okay, this topic is one of the easiest topic. Just have to and get or get, you don't get confused. Just keep doing individual gate output easier. Yeah, as I told you, right, the exam 100 marks. They will cover most almost every topic, right? Okay, so I have to cover all the topic. There is no such topic which they skip. From every topic also they ask question. So I have to cover all the topic, right? All these are important areas they ask questions. I'm very narrowing everything, but because the exam paper not prepared by me, yeah, right? I do not know. I know the question from this topic. What are the questions they usually ask? So what are the questions they usually ask? Is they ask you to this topic. They ask you to draw truth table from the circuit. They ask you to write expression. This can be one question. Or they use Boolean expression. They ask you to draw logic circuit and truth table. So you see here, they will definitely ask you truth table. They will definitely ask you to circuit diagram. Or they give circuit diagram, they ask you to come out with a Boolean expression or and truth table. Okay, definitely these are the choices. But of course, I do not know which one they are specifically asking. Every exam also they ask these questions. So I know these are the questions only they're going to ask. But in order to answer these questions, you need to know these topics. Yeah, correct. So I'm teaching all the topics. Do not know which they are going to ask, whether Boolean expression or circuit diagram. But truth table confirm they will ask. If they give Boolean expression also, they ask truth table. They give circuit diagram also, truth table. But another part question is, are they going to ask Boolean expression or circuit diagram? I do not know, but definitely they will ask one. So I'm teaching all. Okay. So every topic also I know which are the important areas they're going to ask questions, but specifically which question they're asking, I do not know. So I can't reduce my teaching. So I have to complete all the areas, right, which they ask. Right. That's why this maths topic alone, maths as a subject alone, too many topics to cover. No time to cover, no time. Just nice. The time is to cover the topics. No extra revision we can do. So what I usually do is because I have to finish the entire syllabus because every topic also they ask question. So when I teach itself, I give you an exercise, something like this. So that I just give some practice lah, so that you know the type of question, how to answer. Okay. Yeah, math, including math, math lab, right? You all can write a feedback. When you do the course evaluation, you say the topic too much, too many things to learn within a short duration. Y'all give a feedback, see whether they can able to reduce. Not for you lah, but I mean in future, bridging students. Yes, yes, definitely it's not enough because math topic itself so much plus MATLAB programming. Yeah. Um, I still haven't finished a circuit diagram. I showed you, right? The topics we need to cover. Okay. Truth table, Boolean, logic circuit diagram, simplification. So simplification. Simplification means the expression we need to simplify. Instead of drawing with so many gates, simplification after simplify. Instead of after simplification, this circuit diagram can use lesser gates. Meaning instead of 4 gates, it can use only 2 gates or 1 gate. We can get the same output. So that is the meaning of simplification. Why is simplification needed? If you have more logic gates, your circuit is bigger. When the circuit is bigger, your equipment will be bigger because our RAM, CPU, and the registers, all of them using logic gates, right? When the more and more logic gates put in the board, the equipment will be bigger, right? So when they reduce the simplification, using simplification, they reduce the circuit diagram with less gates, but same output if they can able to get. So the circuit is smaller, the equipment will be smaller. That's how the bulky computers become smaller devices, right? So simplification helps them to reduce the logic gates in the circuit. So when the logic gates are lesser in the circuit, uh, uh, the device will be smaller. Yeah, right. Less power is used. So that's where we use a simplification. The same output can be done using the simplified circuit. We can get the same output using simplified circuit with the same input. That is the purpose of simplification. So how do we simplify the Boolean expression? Very lengthy Boolean expression when we simplify small circuit, right? How do we simplify the Boolean expression using Boolean rules? There is a rule for a simplification. That is the next topic. But are you okay to take care of learn this topic now today? Shanice, no, I don't have Shanice because this one recently they changed the syllabus. We don't have any list of questions, but every topic, whatever I'm practicing, right? Those question only. Your practice. You please practice those every lessons. Okay, I don't have those set topic wise. I'm giving right those practice you. That's why I ask you to screenshot the questions and so you practice those. Okay. Chinese asking the do you have a practice question for every topic? I don't have. Okay, so you see now I try to find I cannot get in the study guide. Quickly I draw myself. You see here, this is drawn immediately. I just draw whatever I think I just draw. Then after that I'll close this because this one I can't save. When I save this, it takes a long, very big space because I'm drawing, right? That's why. So I don't have immediately. I just think of some question I will come up with. Okay. So okay. So for the topic, let me show you. Okay. So this one, luckily, last week finished. Done. This is done. We have done this. So today I intend to complete 3 topics. But what happened? We completed only 2. So tomorrow will be very very rush to do this topic. I also trying my best to go fast. We have done this. So tomorrow left with 4 topics. Topic one also I need to go through, but I will not go through detailing briefly. But topic one also there will be a question. One theory question is there. Topic one theory, I think you can study. So this one is the simplification part. Okay, so if your brain cannot take it, no point for me to teach. Even I teach, nothing goes in waste. Okay, tomorrow morning we will complete the simplification and sequence. Afternoon we will do the set theory. Okay. Set theory probability, again very long topic. I will reduce the set theory and probability, what all important areas, then we'll do. Topic 4 not very heavy, but it's just the laws. But laws you need to memorize, no choice. Those laws you need to memorize. Once you know the laws, simplification is easier. We can't do revision. No time for revision. MATLAB, I can't able to do revision at all. So you please go and practice whatever we have done in MATLAB, because last week itself, I went through very detailedly with the extra practice, the programming practice. Plus Tuesday also we did some practice programming. Okay. Maybe we have a shorter time, about 20 minutes, to explain what is the assignment is. I can't do the assignment for you, but I will explain what you need to do for the assignment. I can give you that briefing. Probably MATLAB we will not have enough time to redo again. Not enough time. Okay, because we need to finish these 3 topics plus the uh, theory topic. Okay. The laws in the slides you can see. Okay, assignment. Okay, what you need to do. Okay, right. First question, we almost I gave the answer, but other questions I cannot give I cannot do the answer with you. Assignment answer you have to do. All right. So let me just give you introduction. Just what it is. Okay. How to solve those questions. All the question you must use MATLAB editor. This one almost done. Then second question is this this question is asking about the topic. This topic we haven't covered yet. The second question you have to do after I finish this topic. This topic. Question 2 from this topic. Assignment question 2 from this topic. Okay, so this question 2 just hold. Next, tomorrow when I teach this topic, I'll just tell you what to do for this question 2 from topic 5. Then question 3 is simple. Using MATLAB expression, try to solve this. Correct. So the expression is given. how to calculate mu. So how do you calculate this? This multiplied by 10 power negative 6 t power 3 divided by 2 t plus 110.4. But where do we get the t value? Where do we get the t value in order to calculate this? So you need to find the t value. So t value in the unit Kelvin, right? So how do we find the t value? So in order to find the t value, first you need to find kinematic viscosity. So this, so function data point temperature in Celsius. Then you need to see the program. Ask user to enter temperature in Celsius. Once you enter temperature in Celsius, it has to convert the temperature to Kelvin, correct? Celsius to Kelvin. Okay. So last lesson we did one question on that. Yes or no? One program, converting program. Okay. So use that program to enter the temperature in Celsius. Ask the user to convert to Kelvin. So when you get the RT value, okay, temperature value, so the program input temperature value in Celsius. You have to given T in Kelvin. So it will convert into Kelvin. Pressure, you also need to input a pressure, P value, pressure. Okay. So if you put in terms of bar, pressure in bar, it has to convert into pressure in PA. So this will automatically convert into 10 power 5 PA. P in PA. Absolute pressure. Okay. Calculate the kinematic viscosity V and display the value on the screen. So if you want to calculate V, you need the dynamic viscosity and density. So you cannot calculate this yet. Okay, you need to first input this and keep this temperature and pressure. Then after that, with the pressure and temperature, and R is a gas constant. They already given the value, R value. R value you can input R is equal to 287.05. It is a constant value, you assign R value. So you know the T value, P value, R value, you can calculate this, correct? You can calculate this. Once you know this value, you can go up. You also can calculate this. Why? Because temperature already T value we are calculating here. So that T value you can use, you can calculate this. So number one, once you input a T value, okay, so you can calculate this first. Then after that, you input a P value, you can calculate this second. Once you have a two values, use 1 and 2, 1 and 2. These two values calculate viscosity. So you need to write a program to calculate. So this is the input. Using this input, after you input these two, straight away calculate this, write the formula to calculate this mu. Mu symbol cannot you write, you can write mu, this word mu. Mu equals this. After calculating this, you can calculate a rho. The rho value is rho. This is called rho. the symbol is rho, or you can say this density, air density. Air density you can calculate, put the line, air density formula. Once air density is calculated, you can find the viscosity formula. Understand? So this is simple. No if else, nothing. Just straight away you keep writing the formula. Input, first two input, T and P you input. Once you input a T and P, convert the T and P into temperature in Kelvin. Celsius, you must use the Celsius. Here you convert P in bar into PA because they have given already P using PA. What they say, 1 bar is equal to 10 power 5 PA. Suppose you input 5 bars, 5 bars is equal to 5 times 10 power 5. This is the pressure in bar PA. Correct? So they give the formula. So already they have given. You do this calculation first. After that, you do this expression, second expression, and third expression. Understand? Just keep writing the statements, formulas to calculate. Okay. This is question 3. Question 4. So they ask you to randomly create the numbers. 10-sided dice means when you roll the dice, how many numbers comes, that numbers they want you to generate randomly. So random generation, how do we generate random vector? Random integer. Do you remember we did for question 1? So you create a random integer into one dimensional vector. Then after that, you just draw the graph, plot the graph. Histogram, I do not remember. Suppose you're generating the rand I. 10-sided dice means how many numbers it used to have? Dice will have 1 to 10 values, correct or not? Random value, how many rows, how many columns you can mention, and within the range. Okay, how many rows? You want one dimension, right? One row, maybe 6 columns. The column and row you decide. The range is 1 to 10, right? The numbers. So it will create the random numbers. Then suppose the random numbers is, let's say for example, 5, 7, 2, 1, 8, 6. Suppose this is the random numbers. Okay. Then you want to create a histogram. Histogram is not, I don't think it is available in our MATLAB. The histogram, do we have histogram? Bar will be better. Instead of histogram, you can use a bar X. Because it's our plot doesn't support a histogram. What is that called? GNU. Let me try. GNU Octave doesn't support histogram. So you can use a bar chart. Let me try. Histogram have lah. You try with the histogram or bar. Okay. Bar or histogram. Okay. So you can try. So you show few random 2-3 times different graphs. Okay, because randomly few times you try run and show the graph, screenshot of the graph. Randomly run a few times, then you can. Then it asking highest frequency, average value. Average value means average X. How do we calculate average? AVG equals mean X, right? Yeah. Then the highest frequency means the number repeated few times. Suppose 6 repeated twice, then it will show highest frequency, not highest number. They're asking highest frequency. Highest frequency means that the number repeated twice or thrice, that is the highest frequency. So you need to write if else condition to compare. The numbers are equal, how many times it's equal. So you need to use a loop to check highest frequency. Okay, you sort the array first, then you see the number is repeated, which is, then you can able to see the highest frequency. Frequency means which number repeated the most. Mode, very good. Mode. The function is called mode. Mode will find the repeated highest, the number repeated the most. It's called mode. Okay. The function mode you can use. So a maximum is different. A maximum is the highest number, the number with the greater value, greatest number. Minimum is the lowest number, least number. That one you use for question 1. In this, highest frequency is nothing but mode, the repeated. Which number repeated many times, that is the highest frequency. Okay. So any more question? Okay, so this is the this one we most of the things we have done. Random and then graph we have done. The highest frequency average also we have done in class. The mode only you had to find out. Okay. No need to mention um, maximum minimum number of roles. No need Chinese. No need. But you need to randomize the statistics vector for number of roles. So roll 1, roll 2, roll 3. For 3 rolls, how many numbers there? Which number repeated the most, and every roll, what is the mean, and bar chart. No need minimum, the maximum number of rolls. They just say the number of rolls. Okay. All right. So question 4 is this. Question 3 is very simple question. It looks very complicated. Just few lines only. Your answer should be. First conversion part. After that conversion, just write the formula. It can calculate for you. You just have to write the formula in the MATLAB line, the program. Write the formula for mu calculation, write the formula for density calculation, write the formula for viscosity calculation. It can calculate for you automatically. You need to input the number of rows. Okay? You need to create one vector for a number of rows. Suppose you're doing roles, role 1 consists of this vector, role 2 this vector, because randomly it's going to generate the vector, right? Roll 3 another vector, 3 vectors. All the 3 vectors you need to find the mean for roll 1, mean for roll 2, mean for roll 3. Then all the 3 rolls, which number is most repeated. Understand? That is the highest frequency. Actually, they never ask average for individual roles, average value of the roles. That means all the roles most repeated average, all the roles average. So you find each average, after that average of average. Okay. You try, then ask me tomorrow if you have still have doubt. Right, start writing the code, and then if you have issues, then ask me tomorrow. No, Chinese. 3 roles also will have different numbers, right? So role 1 will have set of numbers as a matrix. Role 2, you will have a random numbers generated by the computer, right? So there will be numbers. Role 3, there will be certain numbers, correct or not? Suppose 6 repeats here, again 6 repeats here, again 6 repeats here, but other numbers not repeated. So which has the highest frequency? Frequency means repeatedly keeps coming. So now the 6 is the most repeated. Yeah, you need to say that is called the highest frequency. And then they're asking average value of the rolls. So average value of the rolls, all the 3 rolls, you find the average 1, average number value, average 2 here, second roll average, third roll average. This is one of the method lah. You want to do all together also can. After finding 3 average, then find the average of all the 3, just the average. Average of all the three. So just give the average. Understand? Then mode you have to say 6 and 4 repeated. Then you have to say most highest frequency is 6 comma 4. 4 repeated again, same. So then highest frequency 6 comma 4. Suppose here 2 6. Okay, that means the highest frequency only 6. 6 repeated 4 times. 4 repeated only 3 times. So you can't say the highest. Highest is 6. Understand? Okay, right. Any other questions relevant to assignment? Question? Of course, question 1, nobody will ask question because we have almost fully done question 1. Question 2, tomorrow after we finish the summation topic. It's a loop also, but loop with the summation topic. We need to input certain things because the formula you need to understand. Then you can do. Question 3 is a direct question. No if else, just formula to convert, and then after that straight away write the formulas. Question 3. Question 4 only you need to again random. Question 1. Question 1 maximum number. Yeah, each matrix. Every time it generate the matrix, right? 2 matrix, right? So each matrix, what is the maximum? What is the minimum numbers? Yes. Duplicate, if you have a duplicate, that is the highest value. It just shows the highest value only one. Suppose 6, 5, 3, again 6, 2, 1, 4, 8, 4, 0, -2. So these are sorted. You sort first. After sorting, you want to find the highest. The maximum value is in this row is maximum. So if I say A comma B, what is the meaning of this? A is the maximum value, B is the location. Maximum of A matrix. This is A matrix. Right? So A matrix maximum value will be, A value will be maximum value, which will give
Hello?
the maximum value. Yes?
Yeah, so essentially what I'm asking is, like,
Wait,
you can
let
see
me
there are two sixes there. Do we have to find the location of both?
mention, right?
Yeah, yeah, yeah.
Yeah. Let me explain first. This matrix, what is the maximum value? Maximum value is 6, 5, 5, 3, right? This will give maximum value. B is the location of maximum value. So it always take the first location because it's the same number. That's what your question, right? Two maximum value, same number. So it will automatically will show 1, 5, or 5 is also 1, 3 is also in 1. So it shows the location. So these are the position. So so you no need to find every location of maximum minimum. Maximums of a value for first matrix location it will show. B matrix same, you will do find the maximum value. Same thing for minimum function. If you use for A and B, it will find for A matrix also minimum value, B matrix also minimum value. So first round when you run, two metrics, right? So two metrics also, two maximum value, two minimum values. Okay, is that clear? What's your question now?
So we just have to find the location of one of
Location
them,
only,
like not all of them, right?
this function will find the location one.
Okay, okay. Thanks.
This A will be maximum value, B is the location of maximum value. Last lesson we did what? Saturday, Sunday. Same thing goes for minimum x comma y. You use two variables to find the minimum value. So equals to min A. If you say min A, what will happen? It will identify minimum value. So maybe 4 is the minimum value. Let's say we take this as minus 6. This one, take it as 10. Okay. So what is the minimum value now? 4 is the minimum value. 2 is the minimum value. Minus 6 is the minimum value. So it will show x value as 4, 2, minus 6. Y is the location of minimum value. Location is third row. This one is second row. This one is second row. This is the location. Okay, third row, second row, and second row. So you can find the location. No need to separately find the location. This function will show the location. Just your printf, you just mentioned maximum value is x value, then minimum, the location of a minimum value is y. You just write. This is the memory will have the value. Just write the print. You put the memory address, it will print the value. Okay, use the function, this function for minimum and maximum. Okay, it gives the value with the location. Anything else? Matrix function we have done, right? Built-in function, we have learned this 10 functions I taught you: maximum, minimum, sum, average, mean, median in that function. Okay, all right. If there's no question, let me share the attendance. Okay, anyone joined here, the yellow color, the background, the background yellow color is marked as absent. If you are here, please, Frenzen here. Just now, Frenzen came, right? He is the one he asked. Okay. Frenzen is present. Anyone's name to be marked, please type. Mandeep Singh, are you there? Paul Daniel, Chunhao. Chunhao is here. Okay. Okay. Right here. Huang Ningji, J. Wait, Chan marked already. Okay, so I see you tomorrow. Okay, no question, please leave. Okay, no need to wait. Bye. Okay, see you tomorrow. Bye. Bye, class. See you tomorrow. Okay, we'll discuss tomorrow.